Hi everyone, this is Asim. Welcome back to our channel. And today we are going to kick off the mobile app pen testing series. So we'd start with very basics, like finding hard-coded keys and stuff, and then we would move on with in the further parts we would discuss about the Android structure and the different like the deep link issues and maybe native JS debug interfaces and stuff. So we'll be talking about those stuff in later on videos. So stay with me till the end. Also, like in my previous videos, I talked about the API pen testing second part. It was so I talked about a lot of people have not yet subscribed to a channel and stuff. They watch it and then they move on, but they don't subscribe to it. The numbers have improved a bit, but not yet. It's still a lot to cover up. So if you're new to this or if you haven't subscribed to a channel, make sure you do that. That gives some motivation to work more and more. Yeah. So let's start with this. So overview of this video. So what we are going to talk in this video. So first we would be seeing the basics of Android architecture, some of the security features that's there in Android. We would be also showing like the APK structure, and I'd be talking about the different files and what they are used for and stuff. We would be installing APK tool and jadx-gui, so that would help us in decompile apps and look at it very easily. So there I would be showing you a folder file structure and stuff. Then we would be finding secrets and apps. We would be exploiting a real world app which has a bug bounty program, and we would find a secret and see how that could be reported, and you would have fetched around $750 for that. So basically I'm taking an older version of the particular app that's already reported. It's a recent one. And yeah, so most of the part would be practical thing. There would be very basic theory or very small theory concept in the start. As and when theory would be required, I would be adding it into further videos. So for this, that's not a lot to know. Only the basic structure of the Android APK structure that's required. So I would be talking about that. So yeah, so this is the Android architecture. So Android architecture meaning to say the Android open source project or the Android OS. So if we see from the top, so that's the applications where your APKs are installed, like maybe your contacts app or your, let's say, Facebook app, WhatsApp. So all these are applications. Even the contacts or the caller screen or dialer screen that you see, all those are apps. Those may be system apps, but those are all apps. So everything is an app in the like Android ecosystem. The second, the layer beneath that provides functionality to the applications, that's the application framework. So as you could see, there's a location manager here. So like suppose if an application wants to get access to the location, so they would be calling the location manager in the application framework, which in turn would be calling the lower layers, like the libraries that's required to get the location, and the libraries further would require the hardware abstraction layer and all that. So beneath the application framework lies the libraries and the Android runtime. So libraries could be the OpenGL library or the audio manager that gives the audio or sound output. There's this SSL and WebKit. So WebKit is for browsers. SSL is for the secure connection, the HTTPS connection, and stuff. SQLite is for getting the SQL database and interacting with the SQL database. So these are some of the libraries that's in the layer beneath the application framework. Then there's this Android runtime. So every application in this Android ecosystem, so this runs in their own Android runtime. So earlier there used to be Dalvik Virtual Machine (DVM), which is similar to JVM, the Java Virtual Machine, except the fact that Dalvik Virtual Machine was highly optimized for handheld devices and battery-powered devices, whereas JVM mostly runs on laptops or desktop, which are heavy equipments compared to mobile phones. So yeah, very recently, I think from Android 5, that's the Lollipop one. Dalvik Virtual Machine has been replaced with Android Runtime. So what's the benefit is that the app performance has improved because of the two facts. So first is the ahead of time compilation, and the second one is garbage collection. So it has improved garbage collection compared to Dalvik Virtual Machine. So that's the benefit of Android Runtime. Then comes the hardware abstraction layer. So the graphics, audio. So graphics is basically the screen that's being displayed. Audio, the sound thing, camera, Bluetooth, GPS. All these are the hardware abstraction layer. So there are software that help you interact with the hardware and there. Then on the bottom is the Linux kernel. So Linux kernel is what Android is built upon. So it has all the safety features that Linux has and a lot more. So the basic security features that Linux kernel has is that first of all that it's a multi-user environment. So every user has their own separate home folder and access controls. So that's by default that's provided into the Android app. So every app that's installed into the Android, so they have their own like home space or user ID. So let's say if I wanted to have like let's say user ID, so if I wanted to check my user ID, so you could see that my user ID is 1000. That's a scene. So similarly, every app in the Android ecosystem they have their own unique user ID. So that helps keep process isolation, so that one process cannot access the memory or the resources of other process. There's the secure IPC. So secure IPC is inter-process communication. So in some cases, like let's say you have Facebook app and then you have also the Facebook Messenger app. So since both are developed by Facebook and both are datally signed by the same like by the same developer, that's Facebook. So they can do inter-process communication. So that's also a functionality that's like built over the Linux kernel there. So those are the few things that Linux kernel provides. Well, the majority, the main, I think, the star of that is the secure process isolation due to different user IDs for each of these processes. So we'll be showing, like, we will be seeing a demo of that as well in the second part. Not right now. We are not gonna set up Motion and we are not gonna see that in the current one. This is a very basic static analysis thing. So we'll be using some tools to get some of the API keys which are like this is kind of the low hanging things that you get in an Android application. Yeah, the app sandbox that I already talked about, that each application has a different unique user ID. So there's basically a sandbox for each of the applications. Similar to what you have on a Linux or Windows machine, that you have different user accounts for different users, and one user account cannot access the other user account's data. Yeah, that's what that is. Let's see the APK file structure. So after this, like after this diagram, I would straight away switch to the installation of the tools, and then I would show these file structures in real time as well. So we would be doing a decompilation of a real app as well. So APK file structure. So there's this manifest file, the signatures, assets, compiled resources, native libraries, Dalvik bytecode resources. So manifest file that has the list of permissions that's required, and it shows like it tells the Android ecosystem once you're installing the app that these are the permissions that are required. It also has other activities or classes defined into it, the intent filters. So don't get confused by the words, but I'm just talking what's all there. In some cases, there are hard-coded string variables also in those. So we'll be seeing that as well. Signatures is basically the certificate and the signature that's there. Assets are usually the, like let's say app has a mp3 or the sound files, like games have sound files, games have a lot of assets like maps or the clip art or the sprites, all those. So those are all assets, the images, the videos, all that's hard coded into apps. So those are all assets. So usually those are not compiled as is, they are just added into a folder. Then there's compiled resources. So these compiled resources are different from assets in the case that they have basically all the constants, like Strings.xml is there. So a lot of strings that's used throughout the Android ecosystem, they are basically added into this one resources.arsc file. So it has a lot of XML like public XML, attributes XML. So all these are compiled into one resources ARSC file. Then there are native libraries. So a lot of apps they use libraries. So these could be third party and native libraries. So all these are compiled into one lib folder. Then there's this Dalvik bytecode. So this is kind of the like main thing I would say. So classes.dex. So dex is basically Dalvik executable. So this contains all the Java code and all stuff. So these are all the classes and all the Java files. These are compiled into the Dex Dalvik bytecode, which could be run into the like Android runtime. Resources again rest folder, so these rest folder again has those bitmap and layout and all those stuff there. On the right hand side you could see how these are compiled. So if you see here, so there's this Android application and there's this Android library. So all these have Java and class file. These are compiled into class files, and this Android library is also compiled into class file. Whatever resources both of these have, these are merged and compiled into one resources folder. And then these classes, all the code is that's there, it's compiled into a dex. So both of these constitute an APK. So APK is just a compressed folder. If you rename it to zip and unzip it, so you would see all these things there. But that's not how we would be decompiling it. We would be using APK tool as well as jadx. So let's get our hands dirty. So here's the APK tool installation guide. So I have already installed it. So if you're using Windows, follow this one. Since I was on Linux, so I followed this. So all my APK tool structures is here. So let me show you. Alice. So you could see that both of these are green. So basically these are executable. So if I show you, so you could see that X is for executable. So APK tool and APK tool.jar. So the first thing that you need to do is download this wrapper script, save link as and save it as APK tool. Then download the APK tool jar file. So the latest one is here. It was released on 2nd December. Previous to that, it was released like 1 year, 1 month ago, 1 year almost. So 29th November. So I read the release notes, and there has been a lot of improvements. The Smalley code, Smalley code thing has also been updated. It supports Android 11. So I would definitely recommend, if you are on the older version, upgrade to this APK tool 2.5.0 jar. Then after you have downloaded that, you rename it to apktool.jar and move both these into user local bin if you are on Linux. For Windows, follow these instructions. Then so also make these executable. Make sure both files are executable. So run this chmod +x. Now let's come to this jadx. So jadx is basically a dex to Java decompiler, and then it shows it into a beautiful format or beautiful UI thing. So that's so I'll be showing this as well, how you could use this. So here's the releases page. From here you could download the zip if you're on Linux. For Windows, there's an executable. So this zip also works for like Linux and Mac OS because it's a jar file. And here are some, like, if you search for hard-coded API key HackerOne, you get a lot of reports, which are mostly these are for APK files. So I've taken one of these reports. It was the recent one, April 13, 2020. It was in Zenly. So this is the app identifier. So using that, I downloaded the app, which was a previous version before 2019. So I used this. Like, you just go and APK download. So you would get a lot of links. I use APK Pure. Yeah, this is the APK Pure. You could use APK Monk from anywhere. You could download. APK Sum is also a good site. Make sure you have a version which is released before this, like December 8, 2019, because then only you would find this particular vulnerability, because after that they have updated that. So this is a benefit of like working with Android application, that you get a previous version which you can use and run the exploit on that. Whereas on web application, you cannot like test it or do the same things that's done there. So that's a benefit that you have here. So if you go to this APK Sum, here you get the older version. So if I show you, I think this was the version. So it was released on 7th Feb 2019. And then there was this version which was released on 4th June. So I downloaded this one, 39 MB. And you could see that there's a lot, like it's 99 MB, it's 39 MB. So a lot of things have been added between these versions. So you could check that as well. However, if you are doing a real pen testing, if you are doing a real bug bounty thing, so make sure that you have the latest version. If possible, download it through APK Store and like do a dump. But in dump, sometimes what happens is your information also gets stored. So I prefer downloading from third-party websites, or if you want, you can pull it from your from your mobile phone as well using ADB commands. So I'll be showing that as well in the next parts. This was some issue. So okay, you can download it from here. I did it myself. So after you have that, let's let's open this. So this is a jadx bin. So here I have the jadx tool. So I have a folder called tools android pen testing, and there I have this jadx, and in the bin folder there's this jadx-gui. So if I do jadx-gui, so I would have a beautiful UI here. This is the APK. So once you select the APK, it starts decompiling. You could see the loading icon here on the bottom left. So it starts decompiling it, and it does a short decompilation so that you get the results very fast. And as you go on clicking the application, it go on with decompiling stuff. I think it's already there. Yeah. So let's see these things that I told you here. So yeah, let's see this manifest, signatures, assets, compiled resources, on all those stuff. So this is the APK signature. Before that, yeah, sorry. So this is the APK signature. So whatever certificates and meta information is there, so it mentions it there itself. This is the assets file. So whatever assets are there, like models, so it could be some maybe ML model or something like that. So I'm not sure what's the model say, but it's basically the static files or assets file. Like in web context, the static files are what the assets file are there. Like you have this JSON file which had some things and stuff. There's Crashlytics build properties and stuff. So yeah, that's there. This is the assets file. These Fabric, Google, Kotlin, these so these are all like what do you say, native libraries of proprietary code. So these are not specific to this application. These are library code. So even if you find a bug here, or if you find something there, you won't be reporting it to this particular program, rather to Google or Fabric. So whatever it's there, but mostly you can ignore it because these are what that needs to be included in public format. Meta-inf is the meta information. So you see here all the certificates and stuff are there. ProGuard is basically what helps you obfuscate the application. So most of the applications which have a bit security inbuilt, they use this ProGuard or DexGuard to basically encrypt all the strings or obfuscate all the data so that you don't get straight away class names to identify what you're searching for. It also helps decrease the file size, because like say if you're using a name like super secret class.java, so instead of that it would just replace it with SAC or 3 characters or 2 characters, so that eventually throughout the application, if you're replacing that with that or class name with that, so it basically reduces the file size as well. Here's the AndroidManifest file. So before I go to that, let's see the resources folder. You could see that layout, drawable. So drawable contains the images usually. Here you could see the XML files. So the icons, all these are in the XML format. Then the colors, so whatever colors we are using. So most of these are default colors, and like you won't find any hard-coded secrets there. So I'm just skipping that. Font are what are the fonts that's there. Layout, I think layout is again the same. XML files and the layout of the app. Mipmap, menu, these are all. So there's this raw thing that you should check. So usually contains some of the raw resources, like these Lottie files. So these Lottie files are basically that helps in animation, and Lottie is kind of like in JSON format you write it, and there's this Lottie library which you include. So using that, it automatically gives some beautiful presentations or beautiful animations. So if I show you Lottie animations, so that would help you understand better. So Lottie files, so you get a lot of beautiful animations if you just include this. So, like these kinds of animations. So you could see that Lottie files is only 56 KB. If you included PNG, there would be 50 files. If you included GIF, for the same thing, there would be 575 KB. So it has a lot of improvements, and a lot of apps these days they use Lottie. So when I was making my OmniSec apps, I found that and I learned about this. So that's why I know about this. So you might find some Strings.xml or some not Strings.xml. You might find some important thing here as well. So mark it as you always check this raw folder. Then I think that's all. There's this XML. So XML contains some of the files. You might not find any interesting thing here, but it's good that if you can check it. Another resource, so this is the resource.arsc file that we were talking about. So in this resources, you might find this values. So in the values, This is the strings.xml that contains the actual like strings, this hard-coded strings that's used throughout the application. So this is the convention that developers follow, that they put all the strings in this strings.xml, and then this is used throughout the application. So if I show you this Android manifest, so I'll come back to that in a minute. So let's see the permissions. So these have a lot of permissions like recording audio, wake clock, vibration, reading the phone state, internet, camera, foreground, access file location, course location, network state. So it can access your location, it can access your contacts and stuff. So adding these permissions in manifest file doesn't mean that it's automatically given. It just instructs the Android runtime that asks like these permissions are there. So the permission model on the Android runtime, they would give a pop up to whether you want to allow it or not. So this permission needs to be there so that the Play Store and other applications could straight away know, okay, these permissions are required, so they can display that these permissions are required while you're installing that. In some cases, what happens is they don't ask for these permissions straight away, but later on, like if you are opening, let's say, a camera app, but let's say if you're using Paytm, so it might not ask for the camera permission until you have opened the QR code scanner. So once you open that, if it's the first time, it would ask you whether you want to allow it or not, and then you allow it. Like if you're using Google Pay, so if you do a transaction, it asks you to turn on your Google location permissions if you are doing a transaction. So that's also there. Then there's this application main activity. So we are not gonna talk about this right now. We will be talking about this in the next time. Then there's also about these schemes and host and deep links and stuff. So we'll be talking about that. We'll be looking at some of the very cool reports related to deep link, and we'll try to replicate that in our local thing and see how we could figure out those as well on our own time. So yeah, those were the Android manifest, meta information, assets, library, resources, and stuff. So in most of the cases, the hard-coded secrets are in the strings.xml or Android manifest.xml. So let's have a look here. Let's see if we can find in something in the Android manifest. So you can see there's some Fabric API key, Snapchat key, the value is here. Then there's here this Snapchat kit client ID. Client ID, I don't think it's very like sensitive. If you see here, there's this Android Geo API key, but in the value you don't see anything, right? It's just @string/config Google Map token. So whenever you see @string, that means that it's a reference to the strings.xml. So there would be a variable called config Google Map token. So if I go here and if I search here config Google Map token, so you could see that I got it here, config Google Map token, and this is the token here. And if you copy this and if you check it on the report that was submitted here, so this was where is that, sorry, okay, it might be a different key, but let's come back to this manifest. So we found that there's this Google Map token. Let's see what else we have here. Service filters, activity, these I'm just giving a cursory look. Okay, we don't find anything else here. Let's come back to Strings.xml. So this is one of the tokens that we found. Then we found config mapbox token. So this is the mapbox token. There's a segment token, Zendesk ID, Zendesk token. Then there are some URLs. Let's see down. There's this web client UID. The next thing I search for is Firebase. So if we have this Firebase IO, let's check this for firebase.json. So that's the second thing, .json, whether we have the permissions or not. So permission denied. So in many cases, you might find that this is a public thing. Yeah. If it would have been straight away Zenly v3.firebase.io.com, so I would have tried Zenly v2, v1, v4, and all those stuff as well. So now let's see anything else we find here. Default sender ID, Google API key. Let's check this. So I think this was the API key. Okay, yeah. So this was the API key that was exposed, and this is how this person reported this, and they got $750 for the same. It was recent, April 13, 2020, and they checked it on keyhack. So after you find any token, like let's say we found this Google API token, we found, let's say, crash reporting API key. So yeah, so we found a bunch of tokens here. Like you could see Zendesk ID, segment token, Mapbox token. And one more thing, you would see that this Mapbox token looks like a basic for encoded thing for a JSON file. So if I show you here, JWT types A to B. So Zenly app and A attribute is something this. So I'm not sure how we can exploit this. So I would go to key hacks and check for Mapbox. So Mapbox API key is here. So it says that Mapbox secret key start with SK, rest start with PK public token, SK secret token, or TK. So Mapbox secret, since this is not the SK, so it's not a secret key. So probably we cannot use this to exploit anything. Secret key start SK, rest start with PK. So this is a public token. So probably we didn't have anything here. The important thing that we have, it was this Google Map token, and then another one that we found in the bottom, that was the Google API token. So Google API token was a little over permissive, and that's what that person found. So this was the Google API key, and to check for this, Google. So Google Maps API key. So you check for the different permissions, and then on the basis of that you could report it to the program. There's another good thing to look for, Google Map API, Gmaps scanner, I think. Gmaps scanner. This was another good GitHub project. Yeah, Gmap API scanner. So this is a good one. I have been using this for testing for a lot of these API tokens. So just download this, you run this Python file, it would ask you for the API token. So you pass this API key, however many API keys you find, you just pass it out, and it would show you, it would check for all the APIs, and it would show you whether it is vulnerable or whether it can be used to exploit it or not. So if you find that it can be used to exploit, you could report it straight away. Like this person reported it, that this is an exploit for Google Map API key, and using that they could basically add incur more charges. So yeah, that's how you use JADX. Now I wanted to show the GF thing as well. So let me show you the GF thing. So CD TMP Zenly. So yeah, that was. Now let's see how we can use APK tool to leverage the power of GF. GF is a tom tool, so that's a wrapper over rep. So how we could use its power to search for secrets that's hard coded into, let's say, code files and stuff. So Strings.xml and AndroidManifest.xml are not the only places where a developer tend to hard code secrets. There could be other places where you could find secrets. And for that, what I use is I do this APK tool, then decompile, then whatever output folder you want, like let's say I want this Zenly, and then the app name. So this. So it would decompile the app into a Zenly folder, and then we would go to the Smalley classes. So Smalley is basically it decompiles into Smalley classes. Smalley is kind of .smalley is the file name. So it decompiles into that, and we could see the hard-coded strings there. So that's a lot useful. So to find basically the location of where your actual this Zenly code would be, and not the library code. So we don't want to be looking for secrets in, let's say, Fabric's code or Google's other libraries code, because there could be other hard-coded strings which are valid there, but we don't want that. We are focusing on this particular program. So what we are going to see is the source code. Once we have the name of the program or the name of the app, so the unique name. So this is the app.zenly.locator. So once you have that, so in the source code also you find that it's app.zenly. So here also in the folders as well, you would find it the same way. Like if I cd into Zenly folder, now if I do ll, so you would find Smalley and Smalley classes too. So in other cases you might find more folders with similar name, like Smalley classes 2, 3, or in some cases you might find only Smalley. So either of the way. So what you do is do small star, so it would give list all the folders in both of the files folders. So in smally folder I find that there's this app folder, and from the source code or from the name I already know that it should be in the app folder because the naming convention is app.zenly.something. So app.zenly.locator. So it would definitely be in smally app zenly and then locator. So here I get all the files there. So these are decompiled into smally files, and smally files is basically decompiled from the Java class files. So I would find the, like, I do a cd into this. So let me cd here. So I'm in this folder now. I would run gf. So gf is basically a tom nom nom tool or wrapper over grep. So if I do gf of, let's say I want all the URLs that's there in this particular directory, so it will find all the URLs in this locator directory wherever they are hard coded. So these are some of the URLs. So this is useful if you want to find more subdomains or testing domains. So you might find a lot of subdomains and testing domains there. You can also find some of the deep link formats and stuff, so that would also be helpful. Other thing you might want to check, for, let's say, strings. So strings would give you a lot of noise, but what I do is with strings I also add one more filter, whatever I want. Like, let's say if I want password, so I would do this grep -i pass. -i is for case insensitive. I'm only adding pass, not the password, because there could be some, like, let's say there could be only pass, not the whole password thing. So I do this. So here also get some false positives like user compass and stuff, but yeah, you could check it that way. So that's how I use JADX and APK tool in combination or in unison to find as many secrets as I can. So it might take a somewhat manual effort, but yeah, that's worth that. So I would suggest you that through the weekend, make sure to go through all this, test, let's say test at least 30 applications, decompile it, and just check for these secrets. In later videos, I will be showing about AndroidManifest.xml, what different information we can get from here. There are some application that's written React Native, how you can decompile it and use that, and like use or find bugs in that. Then I would be also showing debug.js and native interfaces and stuff. So all these are very helpful, and make sure you stay with me till the end and follow this. So if you learned anything or if you like this video, make sure you hit the like button, share it with your friends, share it on Twitter, Facebook, Instagram, whatsoever. Yeah, that's it. Have a nice weekend.